Today's lesson, we are going to talk about quadratic formula. The question that we are going to consider is how can we solve the equation of the form ax squared plus bx plus c is equal to 0. There are a few methods to solve this one. As you have seen before, we can use vertex form. We can change this quadratic equation into a vertex form, then solve it. We can use completing squares to solve this one, and a few other techniques. Today we are going to talk about quadratic formula. It can be shown, which we are not going to cover it in this lesson. We can use a formula given by x 1 and 2 means the roots, the first and the second roots of this quadratic equation is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Now b is the coefficient of the x term here, a is the coefficient of x squared term or the leading coefficient, and c is the constant in the quadratic equation. If we know these values, we can plug it back in the equation minus b plus or minus b squared minus 4ac square root divided by 2a and find two roots. The two roots are because of the plus or minus sign. Plus gives you one root, we can call it x1, and minus gives us the second root, which we call it x2. Now, as you are aware of, the square root of negative number does not exist. So this means that if we assign d or discriminant, so d is called the discriminant, to b squared minus 4ac, depending on the value of b squared minus 4ac, we can have three different scenarios. If b squared minus 4ac, or simply d, is greater than 0, then under the square root is positive, so we can have two real roots. So this gives us two real roots. If d, which is b squared minus 4ac, equal to 0, then the answer is just minus b over 2a. This gives us only one real root. If d, which is again is equal to b squared minus 4ac, is less than 0, then obviously the square root of negative number does not exist. This means that there is no real root, or 0 real root. So, the process to solve a quadratic equation is very simple. First, find a, b, c. When you have a, b, c, find the discriminant, d. If the discriminant is greater than 0, go ahead and find the two real roots. If the discriminant is 0, then you know that there is only one real root, and if the discriminant is less than 0, then there is no real root. Now, if you want to know graphically how they relate to the graph of parabola, these are the cases. If d is greater than 0, then we know that there are two real roots. Then it means that your parabola crosses the x-axis at 2 points, or this way, doesn't matter. If d is equal to 0, in this case, then there is only one real root. Then it means that your parabola crosses or touches the x-axis once. So you will get something like this one. If d, which is b squared minus 4ac, is negative, then it means that there is no real root. Then it means your parabola never crosses the x-axis. So these are the graphical representation for the three cases for discriminant. If it's greater than or equal to 0, again, two real roots, a scenario like this one. If d, which is b squared minus 4ac, is equal to 0, there is only one real root, then this is the scenario. And if d, which is b squared minus 4ac, is less than 0, then there is no real root, so there is no x-intercept, meaning this scenario. For our first example, we consider the quadratic equation 2x squared plus 3x minus 1 is equal to 0. We have to find the x-intercepts or the roots. The first thing, as I said before, you will find the discriminant, d, which is equal to. We know that from the equation a is equal to 2, b is equal to 3, and c is equal to negative 1. d is b squared minus 4ac, which is b squared, which is 3 squared, minus 4 times a is 2 times negative 1. This is going to give us 9. Now, negative times negative 1 is positive 1 plus 8. Which is going to be 17. Since 17 is greater than 0, then it means there are two real roots. So our x-intercepts, x1 and 2, they become minus b. Minus b is minus 3, plus or minus square root of d, which is 17, divided by 2a, which is 2 times 2. This is going to give us negative 3 plus or minus square root of 17 divided by 4. There are two cases, plus or minus. If I go with the plus sign, I get negative 3 plus square root of 17 over 4. If I take the negative root, I get negative 3 minus square root of 17 over 4. These are the roots of this quadratic equation. If we simplify this one, if we go with plus or addition, I get 0.28. And if we go by negative, we are going to get negative 1.78. Since the leading coefficient is 2 is greater than 0, then it means our parabola opens upward, and there is going to be two x-intercepts. One is 0.28 somewhere around here, and the other one is negative 1.78. So our parabola looks something like this. Our next example is a quadratic equation with fraction coefficients. 1/2 x squared plus 3x plus 2/3 is equal to 0. We can either go straight and use the fractions and quadratic formula to solve the equation, or we can simplify the fractions and then go ahead and use quadratic formula. So, to get rid of the denominators, we can multiply every term by 6 to get rid of the denominators. So if I multiply every term by 6, I get 6 times half x squared plus 6 times 3x plus 6 times 2/3 is equal to 6 times 0. Now 60 times 1/2 gives me 3x squared plus 6 times 3x gives me 18x plus 6 divided by 3 is 2 times 2 is 4 is equal to 6 times 0 is 0. Now in this quadratic equation, a is 3, b is 18, and c is equal to 4. So d, or the discriminant, is b squared, which is going to be 18 squared, minus 4ac minus 4. A is 3, and c is 4. So if you simplify this one, then we get 276, which is greater than 0. So this means that we have two real roots. So we can say x1 and 2 is minus b, which is minus 18, plus or minus square root of d, which is 276, divided by 2a, which is 2 times 3, which is minus 18, plus or minus square root of 276 divided by 6. This gives us two solutions with positive and negative. Now if we go with the positive one and simplify, we get about 0.23. If we go with negative and simplify, we get negative 5.77. So as you can see, even when the fractions, the coefficients of fractions, we can just simplify it, and then we can use quadratic formula. Again, you could use quadratic formula even without simplifying fractions. Our next example is a word problem which states that we have a rocket which is launched upward, and the equation which describes the height of the rocket at any time is given by ht is equal to negative 4.9 t squared plus 16t plus 1.25. Just by looking at this equation, I hope you can see that the initial height of the rocket is 1.25. So this means that when the rocket is launched, the height of the launching pad is 1.25 meters. The question is, after how many seconds does the rocket hit the ground? This is the rocket. It goes up and it goes down, and it hits the ground here. It is obvious when it hits the ground, h of t is equal to 0. So we have to solve the equation negative 4.9 t squared plus 16t plus 1.25 equal to 0. From this equation, we can see that a is negative 4.9, b is 16, and c is 1.25. So our discriminant d is b squared, which is 16 squared, minus 4, a is negative 4.9 times 1.25. If we simplify this b squared minus 4ac, we get 280.5. So our roots t1 and 2 are minus b, which is minus 16, plus or minus square root of 280.5 divided by 2a, which is 2 times negative 4.9. Now, if we go by either positive or negative, we get that t with the positive one is going to be negative 0.08, and the positive is going to give us 3.34. Since time cannot be negative, so we can just ignore the first solution, and the second solution, 3.34, gives us the time that it takes for the rocket to hit the ground. The second part of the question is the following. We have to find the time that the rocket is going to be more than 12 meters high. Visually, this represents the following. If this is the rocket which is launched, if the height 12 is here, this means that this is 12 meters. We have to find the amount of time that it takes for the rocket to stay over 12 meters high. To do this one, we just substitute h of t equal to 12, and then we try to solve the equation. So we have to solve negative 4.9 t squared plus 16t plus 1.25 is equal to 12. If we bring 12 to the right, change the sign and add 1.29 to it, we get negative 4.9 t squared plus 16t minus 10.75 is equal to 0. Here a is negative 4.9, b is equal to 16, and c is negative 10.75. Our d is b squared, which is 16 squared, minus 4, a negative 4.9, times c, which is negative 10.75. So our t1 and 2 is negative b, negative 16, plus or minus d. If you simplify d, we get 45.3 here. So square root of 45.3 divided by 2a, which is 2 times negative 4.9. There are two solutions, plus or minus. If we go with plus, we get 0.95. If we go with minus, we get 2.32. Now, graphically, this point, which is on the way up, is 0.95, and this point represents 2.32 on the way down. Now, to find how long the rocket is going to stay more than 12 meters high, we are going to subtract these two. So our time, which we are going to show with delta t, is going to be 2.32 minus 0.95, which is going to be approximately 1.37 seconds. So the rocket was above the 12 meter high for approximately 1.37 seconds.